Hello, everyone. I'm Jingnan Liang, a senior specialist of BioEM at the core facility in Institute of Microbiology, Chinese Academy of Sciences. Today, I'm going to share a homemade device which can achieve automatic and high throughput double staining with transferrable grid holder. My job specialized on TM application, including negative staining, atrophying structure staining, and immune labeling, which come from not only our institute, but also other organizations. I process and image around 3,000 samples each year by myself. An automatic bench staining machine is therefore designed to improve efficiency. The ideal bench staining method should meet two requirements. First, it should make the grid operation easier. Second, it should reduce the consumption of stain solution. A transferable grid holder is designed based on a double side clamping idea. The holder had two layers. The hard frame containing soft material is used to fix the grid on opposite edges symmetrically. The distance between hard frame is 3.1 millimeters, and the thickness of soft layer is about 0 to 0.2 millimeters. Since the typical grid diameter is 3 millimeters, the grid can be easily clamped and loaded by soft layer. The symmetrically clamping force maintains the grids sitting well to go through multiple staining and washing steps. Due to achieve fast bench operation, minimal to non-existent light carbonate precipitate is produced, and the symmetrically clamping force is easy to release grids by using a fan tweezers without chemical damage. As the soft layer on the holder is hydrophobic, very little staining solution is taken out from pipe. As shown in the figure, the liquid left on the grid surface is less than 1 microliter. Staining reagent left in the pipe can be used again after centrifugation, so the staining reagent consumption is very low. In addition to achieve bench staining using the holder manually, it can also be mounted on a robotic hand and stained automatically using a computer program. Now, this video shows the process of inserting the grids vertically into the holder, one after another, and following automatic staining. The currently playing image is the device outward appearance. The holder is placed at the loading position on the transfer station. The robotic hand removes the cap of a uranic acid tube and put the holder into it. After staining for a prescribed time, the robotic hand transfers the holder from UV tube to rinse bottle. There is a waste bottle under the rinse bottle. After rinsing for 3 times, the holder is moved to the transfer station for air drying. Lead citrate staining, rinsing, and air drying are the next steps to follow. There are several fans inside the device to export gas like a fume hood. The whole process is carried out in a confined space, so the risk to have lead precipitate is also reduced. This holder has been used in more than 3 sections since 2016, including different species from nearly 80 research groups. It simplifies the staining work and provides good contrast performance. The staining solution can be reused, including lead citrate. Uranium liquid can be centrifuged once every 4 weeks. A lead solution should be renewed in 3 to 4 weeks. Here is an example of a planned route ultrasync section. On the left is a low magnification image before staining. There is no obvious contrast. After staining with lead citrate solution that had been already used for 5 times, the contrast is observed, and there is no lead carbonate precipitate under high magnification. The UA liquid, the UA liquid remains, which has been used to do section stain for many times, can also be used to do negative staining. Most of the negative staining work in our lab is done with the uranium liquid remains, and the effect is secured. For example, as shown in the figure, even small protein, even small protein around 150 kD can be observed at after staining with UA remains. A bacterial picture negatively stained with UA remains was selected as the cover of Science Signaling in 2019. Since the stain solution consumption for ultrasync section is low and the remains UA solution can be reused, we only need 6 millimeter of 2% uranic acid to finish the work of about 500 section stain samples and 2,500 negative stain samples every year. At present, there is still about 10 grams of UA powder in our lab, which was bought in 1977. Based on the current usage, the stock can be used for the next 8 years. In conclusion, using the symmetrically clamping grid method can easily achieve high throughput automatic staining with good and repeatable staining result. It consumes limited, extremely high hazard chemicals. The simpler, the better. This is the end of my report. Here is the video QR code and my email address. Welcome to send me samples if you need or are interested. Thanks for watching.